Okay, we're going to start rational or equations with rational exponents. A rational exponent is just an exponent that's in fraction form. Okay, not too hard to deal with. Again, we want to isolate the term with that. Then we want to take both sides to the reciprocal power of the rational exponent. Again, sounds difficult. We'll take care of that. The one thing that you do have to remember here is that when you are taking the both sides to the rational exponent power, the denominator will represent a root, and if that root is even, you have to consider a plus and minus case. Okay, if the root's odd, you do not. Okay, so let's take a look at this first one here. If I have an equation, x plus 2 to the 3 halves power equals 27. In order to get rid of that 3 halves power, all I have to do is take both sides to the 2/3 power. Okay? Now, quickly here, just a quick review if you don't remember this. If you have some value, we'll use a u here so it's not confusing. If you have some value to a over b power, you have to remember that the a is a power, or an exponent, and the denominator of that fractional exponent is a root. Okay? So what's going to happen here is these are all cancel out, leaving you with 1, because when you have exponents in that position, you multiply them, and 3 halves times 2/3 is 1. So you're going to end up with x plus 2 to the first power, which is x plus 2, equals 27 to the 3 halves power. Now people get worried about this, but really you're saying we need to take 27 and square it and take the cube root of that. Now you can do those in either order. Do you want to square 27 or do you want to take the cube root? The cube root is going to be easier, so if we take the cube root of 27, 27 and the cube root of that is 3, so we really have 3 squared. Okay? And remember, since we took a cube root and it's odd, we do not have to consider the plus or minus case. Then we take 3 and we square it and we get 9. We subtract 2 from both sides and you get 7. So there's your answer. X equals 7. The next example, okay, here we don't have it isolated, so I need to add 48 to both sides. Okay, the 4/5 power equals 48. Okay, then we should really divide both sides by 3 to isolate it. So I get x plus 4 to the 4/5 power equals 16. Okay, now I need to take both sides to the 5/4 power, which again sounds like a mess, not too bad. Okay, I'll show you that. That will cancel out our exponent on the left, leaving us with just x plus 4 equals. Now, again, do I want to take 16 to the 5th power? Probably not, but I can take 16 to the 4th power pretty easily. I'm sorry, the 4th root of 16. The 4th root of 16 is 2, so I really have 2 to the 5th power here, and that seems like a mess, but it's really not that bad. Just think of it, 2 times 2 times 2 times 2 times 2 is actually 32. And, got to go back up here and backtrack for a second, I took the 4th root, so it's really plus or minus, so this actually becomes plus or minus 32. And so when I subtract 4, I get x equals plus or minus 32 minus 4, which equals 28, or negative 36. Okay, and those are my two answers for that problem.